Alright, hello everyone. It's July 29th. Oh, very tired today. We went to Muir Woods National Monument. That was fun, but tiring. And we have a heart problem. Oh my god, I'm not sure if I have the stomach for it. Alright, let's try this. Hopefully it's not as crazy as yesterday's. Strange printer. There is a strange printer with the following two special properties. The printer can only print a sequence of the same characters each time. At each turn, the printer can print new characters, starting from and ending at any place, and it will cover the original existing character. Hey, hold a second. So first is it will only print the sequence of the same character. And at each turn, the printer can print new characters starting from and ending at any place, and will cover the original existing characters. Wait, hold on. I don't understand. The printer can only print the sequence of the same character. Each time is the same sequence. I got that. At each turn, the printer can print a new character starting from and ending at any place, and will cover the original existing character. What does that mean, cover the original existing character? Given a string S, return the minimal number of turns the printer needed to print it. At each turn, the printer can print new characters starting from and ending at any place, and will cover the original existing characters. Okay, so we print AAA and then we print BBB. ABA. Print AAA first, okay? Then print B from the second place. So at each turn, they can print new characters starting from any position, and will cover the original. And it can cover, so I can print any place. So I can do BBB, then this can give me BBBA. I think that's what it means, right? Or I can print this, then it becomes just BBBBB, right? In this I have AAA, and I will print B, so I just cover one, a bit how ABA. I think I got what this problem is talking about. All right, it's asking for the minimum number of turns to print it, and I have an S, right? I have an S as ABA, and I'm asking what's the minimum number of turns needed to print this. Minimal number of turns. Oh, you think? Minimal number of turns. One turn I can print a sequence. The next turn will print another sequence. It can print any letters, right? Next turn will print another sequence. Next turn will print another sequence. And each time you can cover the previous sequence. Okay? I'm trying to think if we can do like DP on this. Like, what type of DP are you thinking about? Well, DP. Given a sequence, we want to ask. I mean, the easiest will be like if it's just the same, right? Then that's one. And if you have something in it, right, you need to have two. But then I think it can like have multiple layer on layer on layer on layer. Okay, I mean DP. Let's say we have S is something, right? Can we say if we know the minimum number of turns of, let's say, this, can we calculate the minimum turns to do this? Is that possible? I mean, we can even say the minimum number of turns to do 100. Okay, how about this? Like, if I know the minimum number of turns to do any of this, okay, anything, then I have a new one. Then we say, if these two are the equal, right? If this ending in A, and this is also ending in A, then the minimum of this will be the same as the minimum of this, because I can just, whenever I paint this A, I just keep painting, okay? So if they're equal, we're good. What if they're not equal? Then I can say, what if I can equal to this? What if this is a B? If they are the same, then I can, when I print this, then I extend. That's a thought. That is really a thought. Like, we find a minimum to print this, and each time with a new one, I just check. If there is a new, and if there is a existing, right, then in that step, I simply print more. But but if you print more, then everybody will be covered, right? Everybody will be covered. Oh, that should be fine, right? If it's already, then it can be covered. If it's not, if it's changed to different, then something else must have printed over. It doesn't really matter. In the previous step, right? In the previous step, I printed over. I just keep printing up to here. And then, I mean, previously, I can just print over. And if it has not existed before, then we don't do it. So in this case, I just go from the first, right? The first one is A. Second one, A, we look at the previous. Find, so this one, I say this is a 1, right? One time. And then this A, we find this A, so it's also one time. Next one, A one time. And B, go, nothing. So B is 2. B, 2, right? So if we go A is 1. B shall be 2. A, so 1. So this A would take 1 time to do because of I checked the most recent one. I take 1 time to do. Is that right? So the total is going to be the maximum of this. 1 time to do. So every time I got a new letter, I just check before. Which means I just need to keep. So the first, like, if all the A's, whenever where you happen, you only need to catch it once, the first time. Right? So what you're saying is the minimum number of times is the number of unique characters. So I'll just say return then set s. Is that gonna be right? 100. That's probably more than 100. Nope. Yeah, that's not right. That's not right. It should be more. Man, I need some more guidance. I thought it was good. Let's say that should be 2, right? If I print all A's, print B. Oh no, that's not 2. Just do this. That should be 3. This shall be 3. Yep. Right? So you can say this A is 1, B is 2. Try to find this A. This A is 1, right? Because you can print A 1 time, and you got this B, right? This B. Now this is smaller, right? This is smaller. So when you go, you find something smaller, then you find this is bigger. So this is printed earlier. So if you print, then you'll print over this. So you say, I cannot print over this. Right? So as you go back, if these values are big, then they are printed later. So in here is not. So it has to be the smallest among these. You find the smallest among these. If the smallest is bigger than this, you carry it. If the smallest is not, then it has to be not the smallest, the biggest among these. Hold on, the smallest or biggest? So what I'm saying is each time we had a new one, we try to find if we have a chance to have something in the previous painted over. And then it only happens if in between this, everybody is larger than this value. If anybody is smaller than this value, then this has to be painted. What? When? It has to be painted because this has to be 3, right? Because that's first is the second time. So it has to be so you cannot print over whatever is in here. Yeah, so in between, right? You have the new values, so in between we have some other values, okay? And then you see the previous one, when is that one painted? And you see some in this, some might be larger, some might be smaller. I don't think they will be larger. I think they will always be small. I think they will always be smaller because it's, well, that's not necessary. Some might be larger. If everybody is larger, then you can inherit. If somebody is smaller, then you cannot inherit, which means that one printed earlier, right? So you cannot inherit. That means you have to print, because that one printed first. Then you print this, right? Then you can print, which means you can print, and then you print this, and then you print all the way to B. So you need to find somebody is smaller than you, so they have to print it earlier, so you cannot print. So I think this has to be this one plus 1, right? This one plus 1, so it has to be 3. So in this case, what do you think? I need to do some, just try some stuff. Okay, let's try, see if this one can work. Yeah, this was just luck, regardless. All right, so we have S, D, F, F, Z, S, S. So we say this starts on 1. Never happened 2. Never happened 3. This immediately, that's 3. Z never happened 4. S, everybody is larger. So this will be 1. This will be 1. So answer is 4. That is not what we want to do. What we want to do is maybe we mix an S here. Oh my goodness, this is still. How about this? Only S and D. Oh, it's just SD, SD, SDS. SD, SD. SD, SDS. SD, SD, SDS. So 1, 2. This go back. This is 1. This go back can. So it has to be 3. Right? This go back. This can be 1. This go back has to be 4. This go back is 1. So the answer is 4. Maybe. Maybe you want to try this? Not very confident. It does make sense, right? But it feels a little bit greedy. We're just saying that the new thing can be formed by checking if we can use the previous one. That's basically our main argument. So dp equal to that's not right. Right, and dp is going to be 0 times n, and dp0 shall equal to 1, because you need one print to get it first. Then for I in range from, come on, 1 to n, with j in range, we shall go from I minus 1 all the way to the front. Okay, for each one we have to check what is the minimum value in this range, right? We need the minimum value and compare. So we can say min steps equal to math.inf, right? And we say if Sj is not equal to Si, min step equal to minimum min step and dpj, right? Blah blah blah. If it's else it's equal, then we break them out. Else we never find it, then basically Si is a new value, so this shall equal to, we need a current max. Current max equal to 1. So dpi shall equal to current max plus 1, right? We need current max plus 1 because it's never been seen before, so it have to be a new one, print a new one, and we'll continue. Nah, not really. We'll have to say current max equals and plus equal 1. Now we can say equal to dpi. And then we continue. Otherwise, we break it out. So they equal, we break out. Okay? So when break out, we have Sj is pointing to the ones equal to Si. So dpj is the thing. Then we check on the minimum steps. Right? We check on minimum steps. Then we say if minimum steps is larger than Would it be equal to? Shouldn't be. So if it's larger than dpj, right? If that, so everybody in between is have a later time. So my dpi can be dpj. Then we don't have to change current max, right? Otherwise, ooh, nice. Otherwise the dpi, no, otherwise for the current one, dpi has to be dpj plus 1, right? Because there are things that's happened beforehand, right? They painted it before, and then you print the j. Then you print j. However you print it, right? You print j. We have something print before, so you cannot continue printing it. So, but there are other things you can print later. So you have to skip those that printed before, and then do one later. Which means dpi shall equal to dpj plus 1, and current max shall equal to maximum current max and dpi. See, that is the thing. That is the thing. Let's don't do this. Let's do it here. Else we do it here. Right? Else we do it here, and we'll break. And then this else we will do. This one we'll do at the end. So we'll break. Else we do this, and hold on. But this will break out, right? This one will break out. We don't do the else. We do this, right? So if it's not equal to, we keep doing the minimum step. Keep doing the minimum step. If we hit everything, we do this. Then we do this. Makes sense. Otherwise, we hit equal, we check this, and we'll break it. So we don't do this, we do this. Okay, so I think this one, if you really want to do, we can just say dpi shall equal to dpj plus int min steps smaller or equal to dpj. Right, smaller than dpj, then you have to add a step. Then we'll break. Then we get else at the end, and we're going to return current max. Okay, let's try this. A, that should be 2. And then ABA, that should be 2. SDS, that should be 4. Strange printer. All right, now we can throw in this, this, this. See how it goes. Nope, that's not the way. Now correct. So we have to keep looking. Yep, this is wrong. Oh, this one's tough for me. Wow, 2 tough ones back to back. All right, let's see. What do we get wrong? A, B, C, right? So we have 1, 2, 3. That's good. A, everybody, so this is a 1. B, I say, ooh, 3. That's not right, because the third one's already printing this, so you cannot print 3. So for this, you shall print, so this actually shall be 4. Ooh, that is correct. So this shall be 4. So are you saying, but it only makes sense, right? So this one shall be printing 5. So it shall be, so what are you saying is we don't do this plus 1. That shall be current max plus 1. That still works, and this one shall be 5. Nope. Nope. Hold a second. What is it not right? Current max plus 1. Min steps smaller or equal to this. Current max plus 1. Wait, why is it not right? I, J, min steps, current max. I, 0, 1, 2, 3, 4. I want 4, right? 0, 1, 2, 3, 4. Yeah, I want 4. That's 1. Okay, min steps is 3. Minimum steps. How is minimum steps 3? Min step, how is min step 3? What? Hold on. DP is not right. Yeah, the DP is not right. This should be 1. 1, 2, 3, right? And then we hit this one. We go back. It shall be DPI. What do we have? 0, 1, 2, 3. 3, 3. Min step is 2. 2 smaller equal to DPJ is false. Right? Hold on. This is not right. Oh, I see. Hold on. We have to do else if min step smaller equal to dpj. Then I say dpi equal to current max plus 1. Else dpi equal to dpj. Now this one looks right. Try this. Oh, it's turning into trial and error. Absolutely don't like this way of doing stuff. I can try. Thank you. I didn't even know. Okay. Let's see if this one's right. Oh, this one looks promising. So you have to be, I mean, it makes sense, right? Because if you go back here, right, you find something that you cannot extend, then you need this one. It cannot increase this because you have something larger than this, right? This B, you cannot do 3 because you have something larger than this one already. So you have to find the maximum among these. And you say, well, what would do that? That's actually not even among these, maximum among everything. So that's reasonable. And we can actually try even, that's probably more than 100. No, it was just hopeful. Damn. Yeah, it's not right. Shoot. Shoot. I don't even know. Let's try to split in half. This one's still wrong, still right. Good, still wrong. Split in half. This one's still wrong. This one's correct. So the second half is important. Or maybe we delete the first half. Oh, I hate it. I hate it so much to do stuff like this. All I want is, so let's remove something in the middle. Okay, so that's good. So maybe we can remove some of the and. This I can do. If it's just this, if it's wrong, I can do. Yes. It's not too bad, right? So what we have? We have okay. Jeez. Okay. J E I D F H O F I. So what I say, this is a 1, 2, 3, 4, 5, 6, 7, 8, 1, F. I say this is 9. I say this is 10. But in reality, it can be, so basically I think I can remove, so I remove KJE. I can remove KJE. I think it will still be trouble if I remove KJE. Yep, I can remove KJE, but this I has to be there. Okay, so let's do a new one. OIDFHOFI, and of course I think maybe D and H I can remove as well, because these are just adding D and H, adding fluff. Oif and offy. Yep. All right, let's see. OIFOFI, right? So 1, 2, 3 is done. This is 1, should be 1. This F, that should be 4, right? And this I will be 5, but no, this is not. How would you paint this? I can paint. Oh. Hold on, I'll be back. Okay. All right, back. Let's try this. Try the 0 first. Add a 0 first. How do you do 4? That's 4, right? Yeah. Oh, I can do not this. I. Then I do F, then do O. That's 3 steps. Then we just do another O. Oh, it's like palindrome. What if we can start from the right hand side? You want to try? 1, 2, 3, 2, 1, 4. You start from the right hand side. Maybe we should go left to right and right to left. That is bonkers. Seriously, we'll go 2 times. Okay, so we'll go 2 times then. It's just guessing, you know? It's basically just guessing. All the S will turn into SS. And that's about it. SDP, current max. I want to N, min steps S. So I say turn minimum of solve S, solve S. So I have OIF, OFI, answer should be 4. Nah, that's just feel. Nope. Nope. That ain't right. That ain't right. I don't know, man. This is it's getting ridiculous. Two rounds, still not right. I'm just trying to select. My goodness. I'm just trying to select one of the test case. Oh, I saved these test cases. I think these are important test cases. It's this one, right? We're failing this one. try to delete something in the middle. Run again. Nope. It's correct. Delete from the front. Nope. Yeah, let me just submit it. I know this one is wrong, but I want to submit it. Maybe it will give me a better test case. Oh my goodness, it's a terrible test case. It's not gonna work. But maybe I can simplify this one better than this one. You know, just like cutting half. I want to know, like, what are the ways? I mean, getting half always correct. That's very frustrating. Oh my god. Okay, keep the front, keep the end. Good. Let's keep removing. This one's still good. Nope. Nope. Oh. Thank you. I'll get Jimbo out. I'll get Jimbo out. And I say thank you. And this one's still wrong. Maybe we can get this one. We get rid of this. Yes. I mean, we can do this. Let's try this one. Yeah, maybe not. Maybe can we get rid of more? Get rid of. Let's get rid of the A. Guessing. Good. All right. What do we have here? D, C, B, D, B, B, C, D. 1, 2, 3, 1. Yeah, it will be 4. We can actually delete this one. We don't need this one. Yeah, what we can do is we can delete all the consecutive ones. Right? We don't really need consecutive ones. So we can delete all the consecutive ones. These we don't need. And this C, yeah, so this one will be 5. D, this one will be 1. So it will be 5, but except 4. So how about from right to left? I have 1, 2, 3, 1. This will be 4. This will be, yeah, 5. This will be 1. So it's the same. Okay, so now we have to figure out how can we make this one? How can we make this one? Say D, C, B, D, B, C, D. How can we make? Okay, so I can do all D. D, 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 that's 1. And then I can make, because I handle these D. Oh, I have these C. Oh, no. But there's C, 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 C. And then we have B. B, 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 C, D. And then last one we hit. Oh my god. Yep. That is. Yep. That's it. It's 4 steps, right? 4 steps. You change it back, right? You turn this into something else and you change it back. Gosh. And these are palindromes. Are we having trouble with palindromes? Palindromes. What do you think? What if we change the strategy? And of course, we'll always get the consecutive ones. We just delete the consecutive ones because we don't need consecutive ones. So we have all the single, right? Everybody is single by themselves. And then maybe we can say define the ones with the most occurrence. We just set them first. And then we find the ones next. We set those. We find the one next, we set those. Find the one next, we set those. But eventually, all the ones that has been set, not set, like being covered, has to be redone, right? Or we find the one on the outside, right? We find the one on the outside. So if we have someone on the outside, when you set them, it won't be unset. Does that make sense? The ones on the outside, when you set them, it won't be unset. The ones on the outside, once you set, because there's no, you don't want to paint over them, right? So you go to the 2 extremes. Let's find this one. This one, if I simplify this, right, we can actually copy and paste this. Let's do some simplification on this one. Right, so all these are just fluff. BA, we delete all this fluff. These are all fluff. They can be printed once. Okay, so when we simplify it, will be this. So I say, I do print on the outside. Okay, if I print on the outside, and we find everything that's, so we can print on the outside. So can we print this? D, C, B, D, B, A, B, A, B, A, B. No, D. Oh, that's way too much. Let's just maybe do half of this. But it's important if we do this, right? It's important we understand. But how are we going to understand if we don't do this? Dear Lord, D, C, B, D, B, A, 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 and then we have a D. That is not the way to go. We have a D. C, B, C, A, B, D, B, D, C, D, B, A, B, D, B. What I'm saying is, if we go from outside in, we find all the D first. D, and D. We find all the D's. So we turn all the D's into D. Okay. Then we do but on the other side it's gonna be B. So if you do all D and you do all B, right? We just take 2. So we say, okay, we can take 2 to fit these two. So we take this D, that's gonna be 1, this is gonna be 2. Okay, then we go inside and we have a D and a C. Or we have a D, we have a B. We look in. So they have to be different. So we're going here and try to see if this is equal to this. If this is equal to this, I can do, this is 1. And what if this is equal to this? I still don't have a good system for this. I'm gonna give up. Wow, 2 days in a row. Not good. Do we have any hints? Remove boxes. DP. Yeah, it's supposed to be DP. I can't think of anything DP. I don't want to give up, man. I don't want to give up because yesterday I was already given up. DP. How are you gonna consider DP? So I'm like, this is not right. Okay. So what I can see is, let's say, DP from, you know, I to J. That's another thing I can think. DP from I to J. But the thing is, if you know DP from I to J, how does it help? Right? They have D, C, B, D, B, C, D, right? If you know DP at any range, how would it help? Because I want DP, let's say 0 to 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? This is what I want. And can we do, yeah, well, let's write it out. See what we have. 2, 3, 4, 5, probably 6 actually. 1, oh my god, 2, 3, 4, 5. Okay, we have 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay, so everybody by themselves is 1. And we only look into the top half. We don't have to worry about the second half because it's always going to be small, big. So row is going to be small, column is going to be big. So these we don't have to consider. So it's a triangle. Okay, so 0, 1. In this case is 0, 1, 2, 3, 4, 5, 6. Now 0, 1 is going to be 2 because these are different. Okay. How about let's do 1, 2. 1, 2 is going to be 2 as well. 2, 3 is going to be 2. 3, 4. Everybody's going to be 2. Yes, because I have simplified them. If you don't, then they're just going to be a bunch of 1s, which is okay, right? Which is okay. So now, how about we do 0, 2? Okay, 0, 2. Well, 0, 2 in this case is going to be 3 because we don't have anything. 0, 1 is all different, so 0, 2 is going to be 3. This is going to be 3 because they're all different. Now here is different. 2 to 4, right? 2 to 4. 4 looking at this and this, so this is actually going to be 3. And 3 to 5. 3 to 5 is going to be... No, hold on. That's not 3. My bad. This is actually 2. Right, this is actually 2. 3 to 5. 3 to 5. They're all different, so that should be 3. And 4 to 6. 4 to 6 is going to be equal to 2 because 4 to 5 is 2, and then this and this is equal, right? These are equal. So this is going to be 2 as well. I don't know, I'm just trying. Now 0 to 3. 0 to 3. Well, 0 to 3. What can we learn from 0 to 3? Well, 0 to 3, if we say, if we do 0, 3, right? Because this is equal. So we do 0, 3, we just one paint. Then that's one step. Then we have to find a 1, 2. So that's one step plus 1, 2. So how much is 1, 2? 1, 2 is 2. So 1 plus 2 is going to be 3. Okay? Is that going to be the smallest? So you just go look for the previous one and you say we're just going to paint in one shot this whole thing. Not sure. I mean, this one works because I can. 0 is the front. Because other than that, its original is 3. So if you want to paint it, it'll be 4, right? But you can only find the first one to do this paint. You can only find the first one, first occurrence. You can do the paint. You say, "I'll including you," right? I including so your paint does not take any step. So let's try. So this one will be 3, right? And then we have to do this because I want very rich everybody to be taken. So now it's a 1, 4, right? 1, 4 is B. So the first B is this, okay? Then we need to know yeah, because we only want to paint 1 to 4. 1 to 4, how many steps? So 1 to 4, I cannot. I can only paint 2 to 4. I know 2 to 4. But 1 to 4, yeah, how do we find this? To find 1 to 4, I go look before. I find 2 to 4. Right, I have 2 to 4. I know 2 to 4. 2, 4 is 2, right? 2, 4 is 2. So I say And the minimum of this is 2. So I can do 2 plus 1, whatever this, right? Okay, so we have something equal. Otherwise, so I have the minimum of all of them. Now I just add a new one in, right? So I can new one in, I can always add to itself, or we can look, the new one will look for anybody that's in it. So we can say if anybody's in it, I'll do this because that's the minimum, and then we add whatever minimum to the outside, right? And then we do the minimum to whatever minimum is outside, until if we include the entire thing, then we add in inside. So in this case, this B I find is here, right? I find it's here. So 2 to 4 is 2. So this will, I'll say, will be 3. Okay, so now it's 2 to 5. 2 to 5. 2 to 5, this one does not exist. So it should be 2 to 4 plus 1. Alright, because you can do 2 to 4, this one doesn't exist. So 2 to 4 is a 2, so this will be a 3. 2 to 5 will be 3. Now 3 to 6. 3 to 6 is the same, right? So we find 6 is equal to this. So we can do 1 and then add a BC. Add a 1 in the middle. Because other than that, there's no other way. Other than that, it's going to be 3 to 5 plus 1. 3 to 5 is 3. So either 4 or 3. So this will be 3. Now 0 to 4. Okay, now we do 0 to 4. 0 to 4. Right? 0 to 4. B, I find this. Right, so I have 2 to 4. So 2 to 4 is 2. So I can do 2 to 4 and 0 to 1. So this is 2 plus 2. So I say this might be 4. I'm not sure, but this is how I think. Now 1 to 5. Okay, 1 to 5. So 1 to 5, what I can do is 1 to 5, because this one equal to this. So I just do 2 to 4. 2 to 4 is 2 plus 1 to 5, that's 1, so that would be 3. Right? Because other than that, there's no other way. And last one, 2 to 6. 2 to 6. Well, I find D is here. So 3 to 6. 3 to 6 is 3. Okay? So this is 3. So plus 1. So this one will be 4. Now we do 0 to 5. 0 to 5. So we do 1 to 5. 1 to 5 is 3. So plus 1. So we 4. 1 to 6. 1 to 6. 2 to 6. 2 to 6. 2 to 6 is 4. 4 plus 1. No, hold on. No. 1 to this. This shall be 3 to 6. Right? Because that's 3 to 6 plus 1 to 2. What's 3 to 6? 3 to 6 is a 3. 1 to 2 is a 2. So that would be 5. Alright? If I do 1 to 5, 1 to 5 is a 3. Hey, 1 to 5 is a 3. And then I can add 1. So this actually be 4. Yeah, that's the problem. You shouldn't go for D. Right, you shouldn't go for D. You go for D, that's bad. You go for D, it's 3 to 6. Right, 3 to 6 is bad. You should do the other one. You should do 1 to 5, because the whole point, right? The whole point is to find the best. To find the best. To find the best. Maybe I shall go this, right? To find. So go this. We shall this by itself, or this, or this, or we should go through every single possible combinations. Right? We just go through every combinations. This by itself. So it shall be this plus 1. 1 to 5 plus 1. Right? Or we say, I'll get these, and you get this. Or I get this, you get this. Or I'll get this. But you do this, well, actually, they're probably never going to work. Yeah, maybe. Maybe. I just, we do this, this, this. Yeah, we just like, we do this first and then do this. Right? We do this first, then do this. So until you find this, then this one will be slightly different. Then we do this. So this will be 4. Now we have the last one. Right? We have the last one. So yeah, we can do D first. So yeah, it will be 1 plus 1 to 6. Right? 1 plus 4. Or maybe 2 plus 2 to 6. Right? Or I can do this. Right? So 0 to 2. 0 to 2 will be 3 plus 3 to 6. 3 to 6 is 3. Or 0 this. 0, 3. 0, 3 is 3 plus 4 to 6. That's 2. That's also 5. Right? Or 0 to 4 will be 4 plus 2. Or 0 to 5 will be 4. 0 to 5, 4 plus 1. So answer is, hey, your answer is 5. I don't think it's 5. I think it's 4. You analyze so much and then the answer is wrong. Oh, you gotta be kidding me, man. Yeah, because this is different. When you go end to end, you have to add the one in the middle. You have to add the one in the middle. The one in the middle is 1 to 5. And the 1 to 5 is 3. And outside is 1, so this is 4. So what's the summary of this? Well, the summary is, well, we definitely go through the whole thing, right? We go through the whole thing. We say this by itself, right? I mean, this is a new thing. We say this by itself, we go the entire other thing. 2, 3, 4, like just keep going until we hit the entire thing, right? Now I hit the entire thing. If the front and the end are different, if the front and the end are different, then there's no entire thing, right? There's no entire thing. Basically, we just hit the last. We'll group this together, and then we hit this, all right? That's that. But if the front and last is equal, then we can have one more chance. So this is kind of how I was thinking right now to do the DP. I have a bunch of test cases that we can try. So I will say DP is equal to 0 times n, okay, for this in range n. Then we say for I in range n, for j in range I to n. Okay, if I is equal to j, I mean, we can actually do this. For I in range, and we do this first, dpii equal to 1. This is the edge case, not edge case, the default case. And now I can go from I plus 1, right? I can go from I plus 1. Not really. We don't want to hit everything. We want to hit this and this and this. We want to hit diagonal, right? Every time we want to hit diagonal. How do we hit diagonal wise? Do you remember? I should. Diagonal wise means you go J, okay, I, and then your I will go down. So you set J first. Okay, you set J first. If we set J first, so J is here, right? And then J is here. Okay, so you go this. And for each J, I will be gosh, for each J, for I is going to be from 0, right, all the way down to it's not I, it should be like K. So I is 0, right, and then I is 1. So I is 1 and J is plus 1. Yeah, so it'll be like this, right? So we will set for J in range from 1 all the way to n. Then for I in range from 0 all the way to n minus j. Right? Because from here, I 0, 1, 2, 3, 4, 5. Right? You cannot get a 6 because minus j. Right? So we have ij. And then what's the next? I plus 1. But j has to plus 1 as well. Because we do this one first, right? ij. And then the next one shall be, so this will be k. K, this is k. Okay? Then j equal to k plus I. Right? Yeah. K plus I. K starting with 1. K starting with 1. And then I is 0. Then j is 1, so 0, 1. And next one, I is 1. And k is 0. Oh, k is 1, so j is 2. So we go 1, 2. Yeah. So now we have ij, right? We have ij. We say start from I, ending with j. We start from I, ending with j. And we need to find out. So what do? Well, we have j, right? Then we just go j by itself. So I to this. So have kij. We need a p. Okay. Then we p needs to be from this, right? So for p in range, we just start from j minus 1 all the way to I, but we don't reach I because we do reach I. That's fine. We reach I. So it should be I minus 1, right? So we reach I. Because what we want to do is to find, this plus 1 plus this, and then this plus this, this plus this, this plus this. So that's when the p hits this. Okay. And I think this shall be, because we want a minimum, right? So maybe we should do math.inf. Okay. So we can say dpij shall equal to minimum dpij for sure. And then and then what? And then dp something something plus dp something something. So dpi to p, right? And then p plus 1 to j. dpi to p, p plus 1, dpi to j. We do all that. And then this is the most important part. If si is equal to sj, then dpij can also equal to minimum dpij, and what? And the dpi plus 1, j minus 1, right? Well, I mean, if this and if they are equal, I'll do the pre-processing as well. If they're equal, yeah, if they're equal, there gotta be something in between, right? If they're not equal, then we start from here, then that shall be it. That's just one of them. Yep. So we'll do the pre-process. We're pre-processing this. Pre-process. We can have group by. Hit the tools, import group by. So ss equal to for k in group by s. I just want a k. That's it. That's all I want. That's all I want. I just need not a k, letter, right? I just need a unique letters. So this will be ss. These are all fine, and then this will be ss, unique. Pre-processing, right? Pre-processing as get non-repeating. Get letters without repeats. Get letters without consecutive repeats. So it'll be this plus 1, basically, right? Because we added the head and tail is equal. So it will be something in between plus 1. So we do that, then we will return dp 0, right? Because we want to find the 0 to the end, will be n minus 1. Is this correct? This is not correct. Something is not right. J before, oh, that's no J, that's a K. Okay, these we pass. Let's give this one a shot. Yeah, we should do this one. Plus, we actually should do this one. And we have a bunch of this to throw at it. All right, let's take a look. Oh my God. Still not right. 417. Nope. Nope. Dear me, man. Output 16, answer is 15. Okay, I have another idea. Okay, so yeah, we do this. Okay, so every time they're equal, we'll hit it. Every time they're equal, we'll hit it. So we say if ss p, no, p plus 1, Okay, so we start from this, from the one. If p plus 1 is equal to p plus 1. Now p is here. P, no, S is p. Right? Because we do p, we can do this and this, or this and this. Actually, there are two different types. Okay, so we say S is p, because that's the one we're looking at. If this one is equal to S is j, then we can do this one first. Right? We do this one first. dpij will equal to dpij and then dp. So p equal to j. So that's gonna be p plus 1, j minus 1, and then plus dpi all the way to p minus 1. Right? Because p and j is the same. Right? P and j is the same. And p and j is the same. If p and j is the same, then what if I is equal to p? What if I is equal to p? Then p minus 1 will be negative. Right? Will be negative. So what we need to do is make sure I p minus 1 will be a 0. So maybe I should set it to 0 first. If we set this to 0, then it's fine. It will hit some place that we have not hit before. So if we set it to 0, set these to 1, every time we want to go, I set dpij equal to math.inf, and now we go through this. If it's this, it's this. Then we set it again, so there should be this, and dp, I just realized I can do also, could be I to p minus 1 plus dp p to j. Right? We have all these different scenarios. So we'll go through all this. Okay. Ugh. That's not right. Even with this. Gosh. Okay, so don't do this. Just trying different things. We still set this, and we just don't allow, right? We can say if plus this, if p is larger than I, else is 0. Okay. Let's try this. Is this one right? Nope. 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 God. I am out of ideas. Seriously, I am out of ideas. I don't know. I tried DP, didn't seem to work very well. Still. This one is also not right. Don't understand. All right, I give up. It's a similar idea, right? But I don't know why this is that's what we do. Actually, I'm not sure that's what you do. I don't want to read all this. Can I just see this? L is 0. R is 10. Left and right. J is 2. Let's read. I don't understand. Got this. Each strange printer operation with a triplet, meaning that it prints the character C over the substring. Sequence of operation. For all operations CLR, C equals SR holds. And of course, there exists at least one optimal sequence where for each operation, well, you already said this is meaning that it prints the character C over the substring, and once you print it over, C definitely equal to SR. I don't understand. One optimal sequence where for each operation, how it does not hold? I think what it's saying is, if it's an optimal, right? If it's an optimal, then the end character don't change. I think that's what it's trying to say. If it's an optimal operation, then the last one will always hold. So now we're trying to prove why the last one will always hold. Because if the last one does not hold, right? So we do this, but at the end, the last one changes. Then immediately after this operation, the character at the rth position is C something, but in the end, it must be SR. Printing C at the rth position was useless. Thus, one can safely replace the operation with this. Wait, hold on, I don't understand. Where for each operation, this one holds. Consider an optimal answer, not satisfying this condition, containing one bad operation, where you do this operation with C not equal to SR is end, is the end. So you do an operation, but the R, but the last one is not. So you do an operation, so C is not equal to SR, okay? So immediately after this operation, the character at the rth position is C. Yeah, is C. But in the end, it must be SR. That is correct. And that printing C at this was useless. That is correct. Thus, one can safely replace the operation this with this. We just, don't print at that position, because you extend it, it's useless. It's going to be printed over. So I might as well not print it. Okay. Now that this might still be bad. One can replace bad operations with this iteratively until there are no more. So if it's a bad operation, we just don't do it, right? We don't do it. We go one ahead. We go one ahead. At the end of this iterative process, each triplet will satisfy. That is true, because you're avoiding the bad, so you're doing the correct. Since the new sequence remains optimal, we have proved the lemma. Every position will. Yeah, if you have one position that is bad, which means you do this operation and the C is not equal to SR, right? If it's not equal to SR, then this operation is wasted. So you include it or not include it, doesn't really matter. So we'll just shrink one, right? We shrink up into the position where it's correct. C is equal to SR. It holds. Because if it doesn't hold, then you don't need to go there, right? Why do you go there in the first place? You're wasting your operations. So you don't even go there. So it makes sense. It makes sense. I mean, you can also say this is equal to SL. That also works. So just think about a different direction. So we seek a solution to the problem among the subjects satisfying the condition, which means every operation, the last one, will hold. Okay, we'll break it down into a smaller problem. One way to do this is to consider all possible substrings. I was considering all possible substrings, but I think the condition that I was trying is not right. And find the minimal number of operations required to print each substring using the strange pin, or print each substring. Okay. Given a pair L to R, consider a string T of length L minus R. Yeah, okay. That only has character SR. Makes sense. Let dplr be the minimal number of operations needed to transform T into substring. Okay, notice how this dp definition is based on choosing to print on the indices, and then figure out how many operations will be needed after. For example, 1 to 5. 0, 1, 2, 3, 4, 5. We need 3. Transform. Oh. we consider this first. We consider 0, 1, 2, 3, 4, 5. Transform all O's into, no, hold on. We'll transform this into EETCO, because the last one doesn't change. So to make this transition, we need to print E and T and C. Transforming 4 to 7, 0, 1, 2, 3, 4, 5, 6, 7. 4 to 7, 0, 1, 2, 3, 4. So code is transform E into code. B, the minimum number of operators needed to transform T, which it only consider this into, okay. The base case are the substrings entirely consisting of the same character. As such, it will be 0, since one does not have to do any. That's correct. For example, that is 0. Now to write down the transitions of this DP, consider a substring L to R containing at least 2 distinct characters, like J be the leftmost index such that J is larger than L and is not equal to. We want to transform the substring of this occurrences of SR into this. Since J is not equal to, we'll eventually have to change the character at J's position by printing another character over it. The characters in the substring L to J minus 1 are all equal to SR, so we don't have to change. That's correct. So we will not worry about them anymore for the rest of the algorithm. Now we only focus on when J to R. Correct. Consider the first operation that prints at the position J. We know that we start printing at position J, but we do not know where we end. Let's call the ending position I, so that the operation is SI, because that's the one different. You can call it SJ, because SI and SJ is the same. From J to I, that is correct. Let's see what happens to a fixed I. So I can be at different positions, right? With the operation this, we print the character SI over the substring is J to I. Now I question why we do J to I, it should be to I to J. That's how I would do it. But it doesn't matter. After that, the problem reduces to 2 independent smaller problems. Now the segment is J to I contains this occurrences of SI. By definition of DP, it takes DPJI operations to fix this segment. The segment SI to 1 to R contains R minus I occurrence of SR. Originally we have L to R equal to SR, and we didn't override the range. So there's we did not override the range I plus 1 to R with the operation SI. So similarly, it takes this to fix it. That is correct. That is correct. So because we are focusing on R, that is correct. For a fixed I, the answer is, dear me, where does this 1 come from? So DPIJ, JI is the number to fix from J to I, right? We want to fix from J to I. So the first time we find a, because SJ is the first one, the leftmost, that's not equal to. And then we just try anyway, what's this 1? We first find J according to how we define it above, and we try to, if all possible, I, and take the minimum value from the occurrence just defined. So we find this, and then we try to say, if we end at here, we end at here, we end. But this is SI. Oh, it's SI. Yes, it is SI. My bad, I understood it wrong. It is SI. It is SI because J is the first different value, right? and then we go one by one, and each one we say we want it to end at SI, as SI, right? So yes is from J to I and SI, then we want to fix it. We want to fix it. And then we try every single one, and we'll fix this, fix this. What is this one? To fix to a fixed I, right? We find J, how we define above. Okay, so we find a J, right? So for an LR, okay, we find a J is the first one that's not equal to, and then we'll go from this J to R, we find each I, and when we find an I, we say dp J to I is to fix this substring, right? And then plus dpi is fix the remaining, right? That's the dp part, we fix the remaining. And what does this one do? What does this one do? I don't know what does one do. Seriously, what does this one do? For a fixed I, the answer is 1 plus. It's like we have to do one operation first. Oh, I think that one operation is to fix everything to R, right? We fix everything to R, that's one operation. And then we fix the first none equal to I, and then we fix the remaining. That makes sense. Yeah, I'm not doing bottom up. I'm doing top down. All right, so you read this. Yeah, I will do top down. I think top down will be much easier to deal with. Bottom up is it's tough to deal with. So what's the edge case? Edge case is when it's by itself, right? So I that will be 0, right? And then we'll go through the entire thing. When we find the first one, hold on. IJ, right? DP is going to be IJ. That's just an IJ. So if I is equal to J, we return 0, right? If I is equal to J, we return 0. Otherwise, we're gonna say, actually we shouldn't use let's use this. Okay, we have left and right, so let's use left and right. Left, right, and then we say if left equal to right, okay, then we need to find the first. So for J in range that's not equal to SR, right? So for J in range from L all the way to R, right? J from the start to the end, and we say if Sj is not equal to Sr, right? If Sj is not equal to Sr, then we need to go find out So we have to go through the whole thing. Okay, so we can say res equal to math.inf. Okay, so if it's not equal to, then for j, not for I in range. Right, so this j is the first one not equal to. Then we have to go through every single one to fix this, basically fix this subarray. Fix the subarray, and the remaining we haven't changed, right? Because we basically say for this j is not right, then we for every I, okay, for every I, so this I, do this I equal to the j. It's equal to, yeah, which is start from j, right? Start from j, which is fixed by itself, right? Fixed by itself. If we fix by itself, yeah, how many is it gonna take, right? If we fix by itself, so this is a number of steps it takes to fix the array into what it needs to be, right? Number of to fix, right? To fix. So from j all the way to right, because we don't take the right. So because we want to fix, right? I want to fix. So we go this. How much does it take? It's to take nothing to fix, right? It take nothing to fix. And we do this with a different thing, or we take something to fix. So now from I is this, so it's gonna be from j to I, right? J to I is the number it take to fix, So what we want to know is from L to R, right? From L to R, what is the total cost to fix? So we find one is different, so we get the total that need to fix. So we get that. And now I move on to the second. I think that's the only thing we need. We just need to find the first one that's different. Then we can fix. That's it. Right? We just to find the first one that's different. Then we just go through the whole thing. Right? And then for this, we can say res shall equal to the minimum. Res. One is set everything to SR, right? And then we'll fix from j to I. Then we'll fix from j to I. Then we fix from I plus 1 all the way to R, which is exactly the same as this thing, right? So we'll go through all this and we'll break out, right? We'll break out. When we break out, then we'll see, we say return res if res is smaller than math.inf, otherwise return 0. Return 0 means everybody is the same. So we say from func tools import lu cache, or cache this, right? All right, I'm gonna try this. If this is good, then we'll write something more. If it's not good, then I have other things to do today, so I have to call it. Is this one right? We missed by 1. We missed by 1. Why? Why we missed by 1? I think we'll set it by 1. No, that's not right. Fix. What did I do wrong? Yeah, we have a +1. You see, we have a +1. Why do we need a +1 at the end? Did he explain why we need a +1 at the end? Oh yeah. The first print operation, which is not considered the DP. What? Oh, yes, because, oh my goodness. Yes, because DP LR is the number of steps needed to fix L to R, which means we already printed L to R. So that's why we need to add 1. Then this will be correct. Oh. Big fail. But this one is very tough. I'll have to write some stuff. Oh my god. Submit it first, and then I'll deal with this after. Gosh, this is probably one of the most difficult I've ever done. All right, I gotta sign off. Well, we'll get back to that. I have